geometric mean is the positive number x such that a over x equals x over b. All three of these variables, a, b, and x, represent numbers. X is obviously going to be the same number there. So mean is also interpreted as average. So we're finding the geometric average between two numbers. So it's not necessarily going to be right in the middle, but it's going to be the value that makes the left ratio equal to the right ratio. So on this first example, find the geometric mean of 3 and 12. 3 and 12 are representing the a and the b values. So if I take those two and substitute it into that proportion, we'd have the proportion 3 is to x as x is to 12. And x is going to give us our geometric mean then. So when I go to cross multiply, what's 3 times 12? 36. And x times x? X squared, good. How do I undo a square? Take the square root, and what's the square root of 36? 6, good. Could be negative 6, remember that. But we're going to assume they're all positive numbers because we're dealing with lengths. We can't have negative lengths. Good call. Alright, so number 2. Find the geometric mean of 15 and 20. 15 and 20 represent that a and b. So you're saying 15 is to x as x is to 20. Cross multiply, solve for x. No decimal answers today. So if that means it's not a perfect square, you're going to have to break down the square root symbol. Kind of like we did a couple weeks ago. Almost a month ago.
Oh, you got it.
What's 15 times 20? 300. X times x is? Okay, so now I know I need to take the square root. 300 is not a perfect square, so I have to find a perfect square that evenly goes into it. 100. How many times does 100 go into 300? 3 times. What's the square root of 100? 10, and we don't know what the square root of 3 is, so then our x value would be 10 square root 3. Okay, no decimals today, so if it's not a perfect square, you gotta break it down using your square roots. This would be called exact form. Whenever you have radicals, it's called the exact form. We're gonna try one more. You should have space there on the right side. Find me the geometric mean between 16 and 64. No, because there's an equal sign here, so you can't simplify through an equal sign. If like the 64 was already equal to 16, then you could. Good thought though. To make you less calculator dependent, x times x is what? X squared. And that would equal whatever 16 times 64 is, right? Okay. And how do I undo a square? I take the square root. Well, wouldn't I be taking the square root of those two values? What's the square root of 16? What's the square root of 64? What's 4 times 8? Is that what you got when you multiplied 16 times 64 and then took the square root of that giant number? Okay. So you don't necessarily have to use your calculator if they're perfect squares. You can just take the square root of them individually and then multiply them together. Cool, huh, Cole? He's got a look of disgust on his face right now. Alright, geometric mean. Theorem 7.3 says that the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original one and to each other. So triangle ACB here in the right triangle, the altitude, also known as the height, goes from the right angle to the hypotenuse here. When you throw that altitude in, it makes your one triangle two right triangles that all three of them are similar to each other. So they're all going to be the same shape, they're just different sizes. You got a big, a medium, and a little. which means they all have the same angle measures, but their sides are proportional. Okay? So we're going to practice doing what we just did on the whiteboard on the bottom here. So the big triangle represents my big triangle ABC. What letter should I put at the right angle? C. Let's make the bottom this time our shortest side. So I'm going to make the bottom of this triangle the shortest side of triangle ABC. So would I name it AC or BC? AC, right? When I look at your picture, doesn't AC look shorter than AB? Okay, so then I'm going to put my A on the bottom, then I'll put B on the top. My middle triangle, I want the bottom segment to be the shortest side of it. That's going to represent the medium length one, or the medium sized one, which is on the right side. So triangle CDB. Which letter, which vertex should I name my right angle there? D. You might have to look at yours. Is DC shorter or DB shorter? DC. So then I want to put the C at the bottom and then the B at the top. And then triangle 2, which is going to be our little tiny guy, the small one. Triangle ABC. Again, I want to keep the shortest side on the bottom. My right angle is named what? D. So in our tiny triangle, is it AD or CD that's smaller? AD. So I'm going to put A on the bottom with D, and then C up here on the top. So when you label it that way, all the bottoms correspond to each other. They're all the shortest sides of the triangle. All the left sides correspond. They're all the medium sides. So if I were to label my triangle like this, I can take 3x and 7 and put it down here. AD is 3, CD is x, and BD is 7. And then we'd be able to set up a proportion. 7 in the medium triangle is to x in the small triangle, as x in the medium triangle is to 3 in the small triangle. And then you would cross multiply and solve from there. Okay, kind of like what we just did on the whiteboard. That's one way to solve similarity in right triangles, redrawing the triangles. You just have to make sure you put corresponding parts in the same location. Capiche? Okay, it's your choice how you're going to do this. Your second choice is on the other side. And there are so-called shortcuts, if you want to say so. To use the shortcuts, you have to, A, memorize them. It's not what I have in orange there. And B, you have to know how to label the triangle correctly. Okay? So, following from the theorem come the two shortcuts, and I'm not going to read them for you, but I just want you to see the words here. See how they have geometric mean in there? Okay, the shortcuts are going to prove to us that there's geometric means within our picture. Your picture is already labeled. I have my big right triangle, ABC, my medium one, and my tiny one. In the giant triangle, ACB, AB is the hypotenuse across from the right angle. Sounds familiar, right? We should have gone through that before, in like middle school and stuff. Just nod your heads for me. Okay. In a right triangle across from the right angle is always the hypotenuse. The other two sides are called legs. So on your paper, you should see a leg 1 on the left side and a leg 2 on the right side. You with me? Okay. The altitude starts at the right angle and then it goes perpendicular to the other side. And that should be labeled altitude for you on your picture. And then the other two parts. When you drop the altitude, it cuts your hypotenuse into two segments. And we name them adjacent leg 1 and adjacent leg 2. I think yours says like adjacent segment leg 1 and adjacent segment leg 2. Wherever leg 1 is, adjacent leg 1 has to be attached to it. So my little ones align. Wherever leg 2 is, adjacent leg 2 has to be attached to it, so that wherever my 2 is aligned. Okay. So the first thing with these rules, you have to make sure you know how to label the triangle. Your 3 rules are already typed out there nicely for you on the right side. The first rule says, what does it say on the top? That first proportion.
Adjacent segment leg 1 equals over altitude equals altitude over adjacent segment leg 2.
Good. Adjacent leg 1 is to the altitude as the altitude is to adjacent leg 2. The altitude is representing a geometric mean. That's what that first corollary says. If you were to go to read that first corollary, it says the altitude is always a geometric mean. Thanks, Peyton.
Hey, no problem.
Fred, what's the second proportion say? Your second shortcut.
Adjacent segment L1 over L1 is equal to L1 over hypotenuse.
Good. Adjacent leg 1 is to leg 1 as leg 1 is to the hypotenuse. Here, the leg is representing a geometric mean. So if I gave you the leg value, you'd have to put the same number in both spots. Cool. Jackson, what's that third rule say?
Adjacent leg 2 over leg 2 is equal to leg 2 over hypotenuse.
Excellent. The second and third rules are pretty much the same. It's just that one uses leg 1 and adjacent 1, and the other one uses leg 2 and adjacent 2. But your leg is still the geometric mean. Okay, so for these 2B shortcuts, you have to know how to label your triangle and memorize them. The more you use them, the more you say them to yourself each time you write them out, you'll remember them. Just like you first learned to write your name. The more you wrote it, you got to figure it out. Right, Angel? Okay. So we're going to try the first example together, example 3. We're going to start by labeling the triangle. Which value here would you call the altitude? 6. Good. So write altitude by 6. What about leg 1? What do you want to call leg 1? Yeah, I don't have a value there, but it would be the length of AC, so I'm just going to label it just to get practice. What about leg 2? Is the Y value. How about the little 2? What should I label the little 2 as? Adjacent leg 1. Good. I usually just write adjacent 1. How about my X value? Adjacent 2, because it's attached to leg 2. And what am I missing? The hypotenuse. Good. So the hypotenuse is that whole bottom segment. Okay, you got part A figured out, labeled it. Now part B is just putting them into your proportions. Someone asked me this morning, well, how do you know which proportion to start with? Right now you don't, because it's all brand new. So if I were you, I would just go down in order of the proportions. So that first one, Ross, what's that first proportion say again? Is 2, as the altitude is 2. Excellent. So if I'm using that one and I go to plug my values in, Anna, can I plug something in for adjacent leg 1? 2. Marcel, can I plug something in for the altitude? So that means I can put it again over here, right? Anna, can I plug something in for adjacent leg 2? X, good. And I'm able to solve this proportion now. Cross multiply. 2 times X is 6 times 6 is 36. Divide both sides by 2, and what do we get for an X value? 18. Kaden, the next proportion down, what's it say?
Adjacent L1 over L1 equals L1 over hypotenuse.
Okay, would we want to use that one here? Why not?
We need to find Y.
And what's Y representing? Good, so give me the proportion I should use for Y then, Kaden.
Adjacent L2 over L2 equals L2 over hypotenuse.
Good. Taylor, what should I substitute in for adjacent leg 2? 18, good. You said x, right? But we know x is 18, so I can just substitute 18 in there. Haley, what about for leg 2? Cool, and then I'd be the top of my next fraction, right? Taylor, what about the hypotenuse? Excellent. Your hypotenuse would be 20. I have to take 2 plus 18 to get the whole hypotenuse length. Cross multiply here. 18 times 20. 360, good. Y times y. Y squared. How do we undo a square? Is 360 a perfect square? No. What perfect square goes into it? 36 does. How many times? 10. What's the square root of 36? 6. Can I break 10 down any further? No. So then my y value is 6 square root of 10. Wasn't horrible, was it? Okay. Let's try number 4. Start by labeling the triangle. I'm going to make you label it right now in notes. Yeah, right. If you were in 2nd grade, maybe. Close your eyes. Brad, you can come up and label it. Yeah, like all the parts. Just label all the parts. Ruth, do you agree with his labeling? Yeah. You think he did alright? Okay, cool. Has anyone started doing any of the work yet? Okay, if you haven't started, do some. Find some values of x and y and z. Yes. Yeah, you don't have to start on that one. Some mathematician probably redrew the 3 triangles over and over and over and over again, and then they figured out that there's a pattern within the picture. So that's how they came up with our little corollaries and our shortcuts. I wish I could figure something out like that. Should be my goal in dream. Come up with a new geometric theorem. No, that's not a goal. No PT. Lexi, you got a value solved?
I got x.
Okay, go for it. Put it up on the board for me. Yes, of course. With the proportion. Yes. Oh, no, you don't have to. You can just start with the x part after you plug it in. Bryce, would you agree with our x value?
Yeah.
Job Lex. Nicole, do you have y or z figured out? Okay, good. Yeah. Divide this. What'd you write here? Okay. Y equals what? What'd you put in the picture? Peyton, do you agree that y would equal 16?
16?
Yes. 16. Do you agree? Y equals 16?
16, yeah.
Yeah, not 60.
Oh.
Cool. Good. Grant, you hit G. Hey, did anyone not use all three proportions and they only used two proportions? Why? How'd you do that? Good. You could, since like Lexi gave us x to be 9, just done 25 minus 9 and got your y value to be 16 using your segment addition postulate. It's not drawn to scale if you didn't figure that out. Sorry about that. Ross, do you agree z equals 12? That didn't sound very confident. Gavin, do you agree z equals 12?
Yeah.
Okay, good. You should. Questions on that one? Okay, we're going to do one more. It's not the top one, it's the bottom one. It says solve for x, y, w, and z. You don't have a w on there, it's right here. So if you need to, butterfly open your notes so you have your proportions right there. Now you don't have to flip back and forth, back and forth.
Thanks.
You're welcome. Try to give you guys some wisdom there. Oh man. Hey, how do you make the little toolbar for the QuickTime thing to pop back up? You know what I'm talking about? Not this thing. Like when you first open it up, there's like a little toolbar. Click I don't, but I just. I want the little thing to open up. I don't.
Help.
I was gonna try and pause this, but I need that thing open. Right, click it. No, I don't want to stop it. I want to pause it.
Yeah, you are, I guess. So you don't.
Yeah, you can.